Hi everyone, my name is Aguadina. Today I would like to discuss and present about question 2. So as we can see, this question requires us to use mathematical induction to prove that for every integer n more than or equals to 2, if a set S has n elements, then the number of subsets of S with an even number of elements equals the number of subsets of S with an odd number of elements. Okay, if you still remember our previous lecture on the cardinality of power set theorem, we can construct a table like this as a motivation and to have better understanding about the question. So here, let's recap a bit. Let's say we have a set S containing 3 elements, namely Q, R, and S. Then we can fix an element. For example, we fix element S here, and then we separate the subsets with element S and the subsets without the element S. So now we can clearly see that the difference are just the additional element S on the right side, and other elements are exactly the same. Yep, so regarding this question, we have to check the equality between the number of subsets with even number of elements and the number of subsets with odd number of elements. So if we look at each side of this table, we have 2 subsets with even number of elements and 2 subsets with odd number of elements. Similarly, here, 2 subsets with even number of elements, 2 subsets with odd number of elements. And then, if we look at the entire set, we also have 1, 2, 3, 4 number of subsets with even number of elements and 1, 2, 3, 4 subsets with odd number of elements. So it is clear that they are equal in their respective sides and also equal if we gather both sides all together. Get it? Okay, so now let's move on to the proof part. Okay, so firstly, let the property Pn be defined as follows. Since the question asks us to prove for every integer n more than or equals to 2, therefore, for the basis step, we need to prove for n equals to 2. So, we suppose set S has 2 arbitrary elements, A and B, such that S equals 2 braces A, B. Then, clearly, if we list all the subsets of S, we will realize that half of them will have even number of elements, which are a subset with empty set and a subset with A and B, while the other half of them will have odd number of elements, which are a subset with element A and a subset with element B. Alright, we are done with basis step. The next step is induction step. As usual, for the induction step, we suppose that n is an arbitrary integer such that n is more than or equals to 2, and we suppose that Pn is true. Now, we need to show that Pn plus 1 is true. Let's begin with applying our understanding from the table that we have built before. Since n is more than or equals to 2, then we know that n plus 1 must be more than or equals to 3, and the set S must not be the empty set, right? Thus, we may fix an element S from the set S. Note that every subset of S either contains S or not. Any subset X can be matched up with subset Y that contains S, namely Y equals to X union the element S. Consequently, every matched up subset will always have different parity since a subset Y has an additional element, namely the element S. However, you see, it follows that the number of subset Y with even number of elements equals the number of subset X with odd number of elements, and vice versa. In fact, we also know that the number of subsets of S with even or odd number of elements are half of the whole set. Therefore, the total number of subsets with even number of elements is 2 to the power of k minus 1 plus 2 to the power of k minus 1 equals to 2 to the power of k, such that k is the number of elements. Similarly, the total number of subsets with odd number of elements is 2 to the power of k minus 1 plus 2 to the power of k minus 1 equals to 2 to the power of k2. So what does this mean? It means that the total number of subsets with even number of elements is equal to the total number of subsets with odd number of elements. To be clearer, we refer back to the table. You see, green subsets on the left side, 2 to the power of k minus 1, which is half of the side, plus another half, which is green subsets on the right side, we got the total number for the subsets with even number of elements. Similarly, red subsets on the left side, 2 to the power of k minus 1, which is half of the side, plus another half, which is red subsets on the right side, we got the total number for the subsets with odd number of elements. Hence, by principle of mathematical induction, for every integers n more than or equals to 2, if a set S has n elements, then the number of subsets of S with an even number of elements equals the number of subsets of S with an odd number of elements. That's all from me. Thank you.